Hi, folks. We'll try to learn a bit about Julia, the programming language, and I'll just Google it up. I guess I already did some time ago, and this is its homepage on the web. All right, so let's see what it is. It is, if I remember correctly, this language was made by some academics, right? So let's see what is it really. So, in a nutshell, fast. Julia was designed from the beginning for high performance. Julia programs compile to efficient native code for multiple platforms via LLVM. So, yeah, so it supports the LLVM ecosystem. So, whatever backends LLVM supports, Julia program can clearly get uh, native code compiled into those all LLVM backends, right? All right, so it's dynamic. Julia is dynamically typed, feels like a scripting language, and has good support for interactive use. All right, so as opposed to languages like C, C++, and Java, it is not statically typed, right? It is more of a JavaScript in its type orientation. It is reproducible. Reproducible environments make it possible to recreate the same Julia environment every time across platforms with pre-built binaries. Interesting. We'll explore how it does this. Composable. Julia uses multiple dispatch as a paradigm, making it easy to express many object-oriented and functional programming patterns. The talk on the unreasonable effectiveness of multiple dispatch explains why it works so well. So, what is this? Is this on YouTube? Okay. So, we'll probably see that sometime. General. Julia provides asynchronous I/O metaprogramming. Metaprogramming is things like templates and complex macros and stuff. One degree of indirection from the main code, right? So basically, that's what it is. Debugging, logging, profiling, a package manager, and more. One can build entire applications and microservices in Julia. Interesting. Open source. Open source. Julia is an open source project with over 1,000 contributors. It is made available under the MIT license, so it's under a very liberal license, right? Let's see its ecosystem. Visualization and plotting. Wow, these look like some neat um, plots, some heat plots or something, 3D heat waves or something. Let's see. Data visualization has a complicated history. Plotting software makes trade-offs between features and simplicity, speed and beauty, and static and dynamic interface. Some packages make a display and never change it, while others make updates in real time. Yeah, that's how life is. Plots.jl is a visualization interface and toolset. It provides a common API across various backends. All right. This Makey is a sophisticated package for complex graphics and animations. Users who are used to grammar of graphics plotting APIs should take a look at this. This provides Vega Lite grammar of interactive graphics. Uh, so yeah, I mean, we'll explore this later. So general purpose: build, deploy, or embed your code. Julia makes it possible to build complete applications, write web UIs with this or native UIs with this. So this is a GTK port probably of on Julia, and I don't know whatever this is. Pull data from a variety of databases, build shared libraries and executables with the package compiler, deploy on a web server with this or embedded devices, powerful shell integration, make it easy to managing other processes. Julia has foreign function interfaces for C. So this is, what is a foreign function interface? So basically, this is a technically more precise term for what is called as language bindings, right? For C, Fortran, C++, Python, R, Java, and many others. All right. So Julia can be embedded in the other programs through its embedding API. Specifically, Python programs can call Julia using this. Our programs can do the same with ours. Julia call. All right. Data science. The Julia data ecosystem provides this to work with data sets and perform common data manipulations. All right. There is a fast multi-threaded package to read CSV files. All right. So Julia can work with almost all databases using JTBC and ODBC drivers. All right, yeah, sure. In addition, it also integrates with the Spark ecosystem. That's good. Okay, so basically, it has powerful uh, data analytics oriented capabilities as well, right? Okay, so okay. In addition to this, it is used for machine learning. Scalable machine learning provides a unified interface to common machine learning algorithms, which include generalized linear models, decision trees, and clustering, blah blah. So it is basically used in machine learning applications, scientific domains. Julia is designed from the ground up to be very good at numerical and scientific computing. Yeah, I think this is how why it was some academic. It has come from an academic background. This can be seen in the abundance of scientific tooling written in Julia, such as state-of-the-art differential equations ecosystem, optimization tools, so on and so forth. Julia also offers a number of domain-specific ecosystems such as biology, operations research, image processing, quantum physics, etc. Right? All right. Parallel computing. Julia is designed for parallelism and provides built in primitives for parallel computing at every level. That's good. At every level. What does that mean? Instruction level parallelism, multi threading, GPU computing, and distributed computing. This project achieved 1.5 petaflops on this supercomputer using 650,000 cores. All right. Julia compiler can generate native code for the GPUs. Okay. Packages such as this provide high levels of abstraction for parallelism. Distributed linear algebra is provided by this. All right, it sounds like a cool ecosystem, certainly. Okay, it has a lot of packages. There are over 5,000 Julia packages. These include a lot of things. In addition to these, you can use libraries from this because of foreign function interfaces. All right, so this seems like a pretty cool thing indeed. So there are tools and IDEs and stuff. We'll see that later. Okay, so back to the in a nutshell thing, right? Uh, so what is it in a nutshell? Let's see some Julia code examples. That is it to get us a feel of how Julia operates. All right. So what we are doing is okay. So this is some code and this is a function gets one parameter the local variable so they are dynamically typed we don't name it we just define it right we don't name its type so there's a looping for I from that for I where I is from varies from 1 to 0 z is equal to z squared plus a and return so for y is equal to 1 I don't know what this notation means for x is equal to blah blah I think this means this is an increment, I guess. So from where y is from, there is an outer loop where y varies from uh, 1 to 0.05, where then increment of minus 1, I guess that's what it means. Yeah, and the step is minus 1, and the inner loop it starts from 2, ending condition is 0.0315, and increment or step is zero point 0.5. I think that's what it means. So take an absolute value of Mandelbrot, call Mandelbrot function, do some function call of complex, and if it's less than 2, print some a star. If it's not less than 2, then print an empty line. And all right, so let's run it. Let's see what it does. It will make some pattern, right? Uh, so this is what it is doing. It drew something, right? Okay. So this was the console. What happens in the shell? I don't want a shell. Okay. Okay. Let's see some other examples. Are there any other examples? They don't seem to be. Okay. So it gives an idea, right? So if I refresh this page, will it show me a different example? Let's see. Okay, no, I guess it's the same example. Okay, we get an idea. Let's go back. All right, so let's try Julia in our browser. Okay, so you may want to do something like printf blah blah. Let's see. Let's see. This will just print hello world to the console, and then let's see if we. Uh, yeah. Okay. Okay. So let me define a table. Ah, it's not letting me. Okay. Anyways, we'll see. We'll lay our hands on it later. Okay. So what else? Let us see. What else? Let's try to just download and install it. So I download. If you like Julia, please consider starting us on GitHub. We provide several ways for you to run Julia in the terminal using the built-in Julia command line using binaries provided below. Using Docker images. No, I don't want Docker images. Please see platform-specific instruction. Okay, Julia comes with built-in package manager with downloads and installs packages from the internet. In doing so, it necessarily reveals your public IP address to any server you connect to, and blah blah blah. In Julia version 1.5 and higher, by default, the package manager connects to this URL, a free public service operated by Julia project. Okay, so current stable build is version 16.1. Let's install Windows 64-bit through the installer, and we'll also see its help. So while it's downloading, let's see the help. I think it's the help page is on this too. So what is it saying? Support tier 1 Julia's guaranteed to build from source, pass all tier may or may not build, whatever. We'll see. Okay, so let's see what does Windows help section say. Well, Julia is available for Windows 7 and later for both 32-bit and 64. We highly recommend running Julia using a modern terminal, such as and installing the Windows terminal from Microsoft installation notes. Download run the installer and note the installation directory to invoke Julia by simply typing Julia. The Julia executable directory needs to be added to the path. Ideally, it should automatically do the path addition by itself. Let's see. That's usually trivial for the package managers or installers. It's not a big deal. Okay, so it has downloaded. Let's just install it. Okay, let us just install it. Yes, add Julia to path. Let's see what it does. All right, we run the Julia directory. Let's finish. All right, so this is the Julia shell. So there is this help. So bingo, it's done. So version info. Let's say if I type version. Okay, so it has its shell, right? All right, so this sounds good. This is done. We go back. We have Julia installed now. What to do next with it? What we do next? These guys are doing some research. What is the research? Let's see. All right, so let's see what does the document say. The research. No, we are not doing any research. Okay, seasons of contribution in Google Summer of Code. No, not interested. All right. So this is the documentation, and this we'll see later. All right. Let's first. I was interested in checking something, and that is uh, multiple dispatch paradigm, right? Okay, this is what I wanted to see, and I also wanted to see uh, applications and microservices. This is again a YouTube. Okay, okay, debugging, logging. All right, so let's see. So this has taken us back to the documentation, right? Okay, so let's do the documentation later, right? So we'll we'll see that. But let me just let's see what does it say when we click on learn. There is a Julia Academy. Wow. By watching no exorcism Juliet. I prefer to learn by doing exercises. Yes. The manual. Want to just give it a shot and dive right into the documentation. All right, YouTube. There are also a few online courses that have been created using Julia. Okay, Julia tutorials. There are lots of Julia tutorials. There are some books. All right. Okay. So let's see. This thing looks good. Exorcism thing. And then there's of course the manual. Okay. So this exorcism. Let's see what is this thing. Okay. This basically it seems like a good thing, right? There are exercises and yeah. So let's bookmark this. And let's go back to the getting started guide. All right, so this is the Julia shell that we just saw, and let's say what does the Julia shell say? If you're coming to Julia from one of the following languages, then you should start by reading the section on noteworthy references from Matlab or Python. Let's read the references from C and C++. Julia arrays are indexed with square brackets and have more than one dimension. The syntax is not just syntactic sugar. In Julia, indexing of array strings is one base, not zero base. Yeah, that's a source of very many errors in C and C++. Julia arrays are not copied when assigned. Changing elements of P will modify as well. So instead of a copy, this is a reference, right? Okay. Julia arrays are column major, whereas C. Well, we'll see those later, right? So let's just start doing things in it. So there is this getting started guide, and this seems to be the right thing, and we'll follow this. This seems to be the good thing, right? Getting started manual. Meanwhile, let's go back to Julia. So it will evaluate expressions 3 plus 4, 5 star 44. Okay, I think it retains the last answer in ANS. That is indeed what it does. Define. Okay, let's say if I write not zero, uh, this gives an error, method error, no method matching. Okay, pool. Da, 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 da. Okay, that was just a. Okay, let's try to assign something. A is equal to 5. Okay, B is equal to 100. If I write A star 100, A star B, so yeah, it is returning the value and it's in the shell. Let's see if there are some debug capabilities, dbg, whatever. No. Okay, I think it's enough for now. We'll take it heads on in from this getting started manual in the next video. Bye.